Velocity of a fluid can be written as capital V is equal to ui plus vj plus wk. So u is the component of velocity in x direction, v is the component of velocity in y direction, and w is the component of velocity in the z direction. And I, j, k are the unit vectors in x, y, and z respectively. Now, but this velocity in x direction is a function of x, y, z, and time. So acceleration can be written as ax is equal to du by dt. But the problem is that u is a function of x, y, z, and t. So you need to write it like this. Delta u can be written as change in velocity in x direction can be written as dou u by dou t, rate of change of u with respect to time, into delta t, plus dou u by dou x into delta x, plus dou u by dou y into delta y, plus dou u by dou z into delta z, because it has got components in x, y, z, and t. Now delta u by delta t is equal to dou u, you are dividing by delta t throughout. So delta u by delta t is equal to dou u by dou t plus dou u by dou x into delta x by delta t plus dou u by dou y into delta z by delta t plus dou u by dou z into delta z by delta t. So if you simplify, that means if you take limit here, if you apply limit delta t tends to 0, it will become du by dt, and so du by dt is equal to dou u by dou t plus dou u by dou x into dx by dt. Delta x by delta t will become dx by dt plus dou u by dou y into dy by dt plus dou u by dou z into dz by dt. That means dx by dt is equal to u, and dy by dt is v, and dz by dt is w. So ax becomes dou u by dou t plus u into dou u by dou x plus v into dou u by dou y plus w into dou u by dou z. The same way you can write for ay also, acceleration in y direction. This becomes dou v by dou t plus u into dou v by dou x plus v into dou v by dou y plus w into dou v by dou z. And acceleration in z direction will become dou w by dou t plus u into dou w by dou x plus v into dou w by dou y plus w into dou w by dou z. So acceleration in x, y, z can be remembered easily using this formula. That means dou by dou t of plus dou by dou t plus u into dou by dou x plus v into dou by dou y plus w into dou by dou z into, so for x you can substitute u, for y you can substitute v, and w you can substitute for z you can substitute w. And also this dou by dou t component, this is called the local acceleration. This is called the local acceleration. And this component, this is called the convective acceleration. This is called the convective acceleration. This is called the convective acceleration. Let us do a problem on acceleration of a fluid. The question is, in the fluid, a velocity vector in a fluid flow is given by v is equal to 4x cube I minus 10x square y plus 2tk. Find the velocity and acceleration of fluid particle at 2, 1, 3 and at a time is equal to 1. So we are given v is equal to 4x cube I cap minus 10x square j cap plus 2tk cap. So this u is given as 4x cube and v is equal to minus 10x square, w is equal to 2t. So at point 213 this will become 4 into 2 cube, that is equal to 32, and this will become minus 10 into 2 square, this is equal to minus 40, and this is equal to 2t, that is 2 into 1, this is equal to 2. So this is for at point 213 and t is equal to 1. So velocity is equal to ui cap plus v j cap plus w k cap. So this is equal to 32 I cap plus minus 40 j cap plus 2 k cap. So the magnitude of the velocity is equal to 32 square plus minus 40 the whole square plus 2 square root. So this will give the magnitude of the velocity, and to find the acceleration, you know ax is equal to, according to the formula, it is dou u by dou t plus u into dou u by dou x plus v into dou u by dou y plus w into dou u by dou z. So you know u is equal to 4x cube, so dou u by dou t will be 0, and u we have already found for that point u is equal to 32, and dou u by dou x is equal to 12x square plus v is actually equal to minus 40 into dou u by dou y. So dou u by dou y is 0 because it doesn't have any y component, and w is 2, and dou u by dou z is actually will become, again it is 0. So this is equal to 32 into 12 into, here x is 2 square, so it's equal to 32 into 12 into 4, that is equal to 32 into 48, and ay is equal to dou v by dou t plus v into dou v by dou x plus v into dou v by dou y, sorry here it is u, plus w into dou v by dou z. So this is equal to, so dou v by dou t is 0, v is minus 10x square plus u is 32, so minus 10x square dou by dou x is equal to minus 20x plus v, actually it is equal to minus 40 into dou v by dou y is 0, and w it is 2, and dou v by dou z is 0. So this will become 32 into minus 20 into 2, so that is 30 minus 32 into 40, and a z is equal to dou w by dou t plus u into dou w by dou x plus v into dou w by dou y plus w into dou w by dou z. So this is equal to, so dou w by dou t is 2 plus u is 32, and dou w by dou x is 0, plus v is equal to minus 40, and dou w by dou y is 0, and w it is 2, and dou w by dou z is again 0. So this is equal to 2. So acceleration vector can be written as 32 into 48 I cap minus 32 into 40 j cap plus 2 k cap. So total magnitude of the acceleration is equal to 32 into 48 square plus 32 into 40 square plus 4. Take the root. So in this way you can find out the velocity of the fluid particle.